Grant, please take your seat. Grant, we want to start. Please take your seats. Next speaker is Martin Levitsky from Red Hat, and he will talk to us about leveraging SDMs and others on virtualization.
Welcome. Welcome to the session about using SDM in virtualization. My name is Martin Levitsky and I'm working for the Overlook networking team. In specific, we'll talk about the integration of the Overlook project with OpenStack Open Virtual Network. The agenda for today first, I will give you a very brief overview of software-defined networking and an overview of them. Second, a very brief overview of the Overlook networking. Then I will talk about a feature called Overlook external network providers. And last, we'll go over to the integration between Overlook and Open Virtual Network, the Overlook provider OVN project. Let us start off with a brief introduction to software-defined networking. Software-defined networking is a concept where you programmatically configure all the networking devices in your network environment, such as routers or switches, in order to make your networking environment to appear to have a desired networking, logical networking topology. So in simple words, if you have a physical environment like we have on the left, we configure the switches in such a way that the device is connected to the network, see it as it has the topology on the right. A typical software-defined networking solution is built like this. We have an SDM controller which takes in the logical network topology that we desire. It reads the physical state of the system, and based on those two, it computes the networking configuration for our networking devices, and sends the required configuration to the SDM node. One of the implementations of software-defined network is Open vSwitch Open Virtual Network. It's called OVEN in short. The logo is meant to represent it. OVEN provides us with layer 2 and layer 3 virtual overlays on top of a number of OVS instances that we have in our system. It gives us logical entities such as logical switches, which are the equivalent of Overlook networks or OpenStack networks, logical switch ports, logical routers, load balancers, access control lists, and more. The OVEN architecture. Architecturally, OVEN consists of two layers. We have the OVEN Central and the distributed OVEN controller. OVEN Central consists of two databases. We have the North database, which holds the logical state of the system. This is the state that we desire. And the South database. The South database holds the physical state of the system, and it also holds the mappings between the physical devices and the logical entities. We have something called the North daemon. This is a daemon that looks at the North and South databases and updates the South database to mirror the changes to our logical network topology. The other layer is a distributed OVEN controller. It's installed on top of an OVS instance on each of our networking hosts. It monitors the South database to update it with the physical state of the system and to check the mappings of the logical entities to the physical devices that it controls on the given host. Let us look a little bit deeper into how OVEN works. It consists of, there are three items that enable OVEN. One is a number of OVS instances in our system. The second is the open flow protocol, which allows us to control the behavior of our OBS instances. And the third item is tunnels between our OBS instances. When we look at the basic OBS bridge, it just connects all the ports connected to it to all the other ports on the switch, on the bridge. On the switch. Now, let's introduce the open flows onto it. Now we are able to control the traffic going between our different ports. For example, with some of the simple rules below, we are able to specify that any traffic originating at a port with a source MAC of 1 going to source MAC 3 will be outputted to port 3, but any traffic going from MAC 1 to a destination MAC of 2 and 4 will be dropped. So we are able to divide our OBS switch into multiple logical switches, which will separate the networks into logical networks. Another item, the tunnels between our OBS instances. If we add another port to each of our OBS instances and connect the ports with tunnels, all the traffic from one switch will be moved to the port, will be moved to all our other switches, and in turn all the ports on the other switches will be able to see all traffic originating from the other switches. So in result, what we get is not just multiple switches, independent switches, but one big aggregated switch. When we combine all this, we will have our big aggregated switch consisting of all our switches in the environment, which will be then divided by using the OpenFlow protocol and tools controlling the traffic into smaller logical switches. Let me now go over to give you a brief introduction to overhead networking. I will skip the introduction to overhead. If you are interested, please come to our overhead booth in Building K. I will talk about our native overhead networking. It's pretty nice. It has nice features like bonding, VLAN support, network filters, but it has some problems too. One, it is based on the Linux bridge, so this is layer 2 networking. If we want to create a network and add some virtual machines, to connect some virtual machines to this network, we create a Linux bridge and we attach our port to that Linux bridge. If we want our network to span over multiple hosts, we have to make sure that the appropriate host, we connect the Linux bridge to a NIC on the host, and we must connect the NICs between the hosts. This is a layer 2 connection, so network separation is our problem. We must connect the hosts in such a way that we ensure network separation. Another problem is that since we can only connect one bridge to a network interface, only one network per NIC on a host. We can go around this using VLANs. If we have VLANs, we can have multiple networks on one NIC, but then we must also make sure that our infrastructure outside of the host supports this. Another probably bigger problem is that our native overhead networking can only control the networks within overhead, and our internal networks can only be controlled by overhead. So no external control for our networks. The problem I mentioned 3 slides ago about not being able to control our networks from the outside, in the data center it becomes a problem. The data center is usually not only overhead, we would like it to be so, but somehow people also want to use other systems. So usually you have multiple systems running in the data center, systems that need to connect to each other. If we only have network management confined to our different subsystems, it becomes a problem. What we would like to do is to have one centralized network management system that would allow us to manage the networking over all our subsystems in the data center. So we can create one network, for instance, that all our subsystems would be connected, would be able to connect to. The metaphor is probably not a good one. Somebody pointed it out to me today because in the book nobody liked centralized management and they did it away with. But in the data center it's actually a good solution. So what we came up with is a feature called external network providers. It allows to externalize the network implementation in order to external network providers. It could be any network management systems out in the market. It could be, for example, OpenStack Neutron, or as we will see later, Open vSwitch, Open Virtual Network. One problem that we had to come up with an API that would allow us to control the external network providers. It was pretty tempting to come up with our own implementation, our own API. Reinventing the wheel is always really exciting. But instead we have chosen to implement an already existing implementation, something that is widely used, open and light, maybe. So we chose the OpenStack networking API. If you want to connect to an external network management system, all you need to do is make sure it implements the OpenStack networking API and you can connect it out of the box. So, because of this decision, the first implementation that we had was OpenStack Neutron. OpenStack Neutron uses the OpenStack networking API, so it was almost just enough to connect it, and it was working out of the box. The OpenStack Neutron external provider is available. You can use it. It's still in the experimental stage. We never finished in such a way that we declared it ready to be supported. This is because it was not really live. The problem was that Neutron itself was pretty complicated. Just to install the external network provider OpenStack Neutron, you needed more resources than for Overit itself. So not many people used it. Let me just go over how an external network provider would work in connection with Overit. So we have a scenario where we want to create an external network and then create a port, a VNIC on a virtual machine and connect that VNIC to an external network that we have just created. As the first operation, we would go to the Overit UI and we would click to create a new network. On the Overit network panel, we would just have to click one checkbox, make it an external network, and choose the external provider that we want to create it on. That request would be sent over using the OpenStack network API to the external network provider. The external network provider would create the network. As the second operation, it would talk to the external network, to the network controllers, and create the network in our networking infrastructure. The second operation, we would be creating the port, the VNIC on our VM. We would tell Overit that we want this VNIC to be connected to this specific network. What Overit engine would then do, first it would create a port on the external network provider. The external network provider, usually it would just create a mapping between the logical port and not yet existing VNIC in the system. So probably no interaction with the network infrastructure yet. After creating the port on the external network provider, Overit would send a request to DVSM PDSM is the overt agent on top of our virtualization host, telling it to create a VM on the VM and plug it into the external network. We have a feature in PDSM called the hook scripts. Hook scripts are user-defined scripts which allow the user to plug in into every single significant lifecycle event of a virtual machine. So you can do it either before a lifecycle event or after. You can do it before you start a VM, after you stop it, before you stop it. The ones that we would be interested in are the hooks relating to networks. Like for example, in our case, this would be before VNIC plug and after VNIC plug. In one of those hooks, we would have to tell the network controller on the given host that a port with such a logical port ID was plugged into this specific physical port. So the network controller usually tells the external provider, this has just happened, we have a new mapping logical to physical, and the external network provider would then wire this port to our external provider network. Okay, so let's recap what we know so far. One fact is that overt network management is limited. The second one is software-defined networking is not that easy. OpenStack Neutron is heavy and complicated. The problem with Oven is that we speak OpenStack networking API. Oven only speaks command line, or it speaks OVSDB protocol. So you have to talk to OVSDB directly. They don't have bigger abstractions like network port. You have to do it all manually. So how do we resolve it? If you can guess right, I can offer you a free sticker. That's the only thing I can offer you. Any tools? Yes. So after the session, please come and get a free sticker. What we decided to do is create a project called Overt Provider OVM. What it does, it's just an adapter of from Overt to Oven. So it's an Oven adapter for the OpenStack networking API. I will go back to the diagram showing the Oven architecture, adding two items. So on top we have our cloud management system. Below that we have our Oven cloud management system plugin, and below that we have Oven as we saw before. Our cloud management system, that is Overt. The plugin, it could be Neutron. Neutron is providing support for Oven. But as I said previously, we don't really need all the complication connected with Neutron. We don't need to have a few additional VMs just for hosting OpenStack. We don't need all the complicated configuration. What we need is just a really simple adapter that would allow us to use Oven using the OpenStack networking API. So what we have is a really small process. The code base is less than 100 kilobytes. It's written in Python. It's stateless. It's just a simple adapter. The job initially it was pretty easy. The basic entities in OpenStack networking and in Oven are pretty similar. The OpenStack network is almost an equivalent of Oven logical switches. The ports can be mapped to logical switch ports. There are a few small differences, like the child-parent relationship. In OpenStack, the child takes a reference to its parent. In Oven, it's the other way around. So initially it was pretty easy. So what would come in as an OpenStack networking API call, here we create a new network, would end up with an Oven configuration as we see on the right-hand side. Now, if you notice, the IDs of the different entities are the same. So if you don't want to limit your control of Oven just to Oven, you are free to use the Oven tools like the Oven command line using the same IDs. You are not only limited to Oven. If you want other applications in your data center to also use Oven and to control it, you are free to do so. By the way, any changes done to Oven externally, outside of Oven, will be taken care of, and Oven will be able to handle this too. Sometimes the job was not as easy. In the case of load balancers, we can see on the right-hand side that in Oven, a load balancer is actually one-liner in a logical switch. We only have the bit property tells us the source, the IP, and the endpoints for which should be used for balancing this fund IP. In OpenStack, the load balancers are much more complicated. We have quite a nice hierarchy of different entities that contribute to creating a load balancer. The problem is that we not only have to create an Oven load balancer based on the information that we get from OpenStack API. That would be pretty easy, but we have to also do it the other way around. So if somebody issues a GET request, he wants to get the information about the load balancer, we have to reconstruct the whole object structure based on the little information that we have in Oven. When we worked on the project, we wanted to create an abstraction layer for the Oven database, not to deal with raw obvious DB calls every time, but to create calls for network ports and so on. While working on it, we saw that we are not the only ones trying to solve the problem. Another team that had exactly the same issue and tried to use Python for that was OpenStack Neutron. The code wasn't duplicated, but the result was almost the same. So we talked to them and we decided to pull the common code out. OpenStack Neutron was much further advanced than we were. So the decision was to take the Oven code out of OpenStack Neutron and create a new OpenStack project. So this way, OpenStack OVSDB project was created. If you need a higher abstraction API for the Oven database, you are free to use OpenStack OVSDB. Now, let us look at what we have achieved. The benefits of using Oven in Oven. One is centralized management. This is actually a benefit not only for Oven but for all external network providers. You can use centralized network management. You can manage your networks from outside of Oven. You could also use Oven to manage your other networks. Second benefit is much easier configuration. As I said previously, native Oven networking, it was layer 2 networking. Now, with Oven outside of the host, it's layer 3 networking. So instead of taking care of the network separation yourself, what you need is just layer 3 connectivity between the hosts to create the tunnel. And that's it. You don't really care about anything else. If you reconfigure your network, the only thing you need to take care of is there is network connectivity. So the network configuration is really much easier. Very similar, it's resistant to infrastructure changes. If you have your host connected, you need to change anything in the networking infrastructure. Sure, go on. Just make sure my packets can be routed to the other hosts. When working on the provider, initially it was supposed to be one of the many network providers in our system. We already had the neutron provider. There is one external party that is working on their own network provider for a legacy solution. So it was supposed just to be one of many. But while creating it, we decided that we like it so much that we wanted to create it as a solution next to our native networking. So now the oven provider is available in Overt out of the box. It's supported, one thing. When you install Overt Engine and you configure it, you can specify the Overt provider oven to be installed along with the Overt Engine. It will be automatically configured. It will set up all your keys, all your connections. It works out of the box. The second item, when you installed Overt hosts, VDSM, from the engine UI, you can also request the oven provider OVN along with oven and Open vSwitch to be installed on your host and to be automatically configured to be used with the engine. Another benefit, we now have an OpenStack network compliant proxy to Oven. If you want to use Oven, not the hard way by using the command line or going into OBS DPR directly, you can use it via the OpenStack networking API. We tried to advertise this with some other projects, and there was some interest in some, and we actually managed to convince ManageIQ that it's a good idea. And ManageIQ decided to support networking using our networking provider. So if you now go into ManageIQ, you can add a networking provider based on Oven. Our roadmap at the beginning for Overt, we just needed networks, ports, and subnets. That was it. We don't need to control anything else in Overt. But when ManageIQ started using the provider, it turned out that they need much more than just the two basic entities. They need routers, load balancers, and access control lists, net. Probably there will be more. So far, that's all they want. So network ports and subnets, we already had that. We are almost done implementing routing. It's already partly available in Overt release 4.2. For the next releases, we have plans to implement load balancers, access control lists, net. There could be other things later on, like quality of service, etc. We are getting close to the end. I was actually told every time I rehearsed, I was much over time. So I threw out a few slides like over introduction. I tried to be as fast as possible, and it looks like we are much ahead of time. The summary, what I would like you to remember from this session: one, we now in Overt, it's not only the Overt native networking, we have the Oven-based networking available too, using the Overt provider OVN. The other item, if you are looking for a nice SDM solution, small one, you can use oven using our provider, using the OpenStack networking API, and deal with high-level OpenStack networking abstractions. So, thank you. Do you have are there any questions? Excuse me? The question is it ready for production? Yes. In Obvious 4.2, we support networks, ports, and subnets. This is already supported. Routers are still a new thing. They are being tested. They should be they should be supported. I don't want to state the release, but pretty soon. One other feature, which is it's probably not related to the OpenStack networking API. Our Obvious external oven networks can be connected to the legacy, to the native networks. So you could have a bridge between, you can specify a bridge between an oven network and our native network. Any other questions? Yes? The question is, let me just repeat it, is it possible to use OVSDB app as a standalone application? I don't know, by OVSDB app you mean the OpenStack OVSDB app project, right? Okay, so OVSDB app, it's not a product, it's a library that allows you to access OVSDB. You have to configure it. You have to what you have to give it to OVSDB app is the host of that holds the OVS host DB, the port, and I think the type of connection. If it's SSL, TCP, another item is the keys that you need for the SSL connection if it's being used. So with this configuration, you just click OVSDB app and you are ready to go. You can use the OVSDB app API. Okay, if you have any further questions, I'll be available here for the next half an hour or so. And later on, I will be at the Obvious booth in building K. Okay, or the K. All right.